Hey guys, I'm going to read out loud part 2 of this week's review book assignment, starting on page 45. While I read, I'm going to be underlining important information and making some text annotations. Solar system. In the last few years, powerful telescopes on Earth and in space have found evidence of planets around more than 100 stars. This means that solar system really can refer to any star group of 2 or 3 stars that has non-star objects orbiting it. However, in this book, the solar system is our solar system, the sun and all objects that orbit the sun under its gravitational influence. Parts of the solar system. Most of the solar system in space is space devoid of much mass. However, about 99% of the mass that does exist contained in the sun. The sun is a medium-sized main sequence star, about 5 billion years old, that is the gravitational center of our solar system. A satellite is any object that orbits or revolves around another object. The planets, asteroids, meteoroids, and comets are satellites of the sun, and the moons are satellites of planets or asteroids. Earth has one natural satellite, the Moon, and more than 2,500 artificial ones. Planets. The 8 planets are the largest objects that independently orbit the sun and don't share their environment with other large objects. Planets are generally spherical in shape. Recently, over 1,000 planets called exoplanets have been found revolving around stars other than our sun. Asteroids. An asteroid is a solid, rocky, or metallic body that independently orbits the sun. Asteroids have an irregular shape, except for the larger ones which are spherical and no atmosphere. A large percent of the thousands of known asteroids are in orbit between Mars and Jupiter. Asteroids are smaller than planets, from about 100 to 1,000 kilometers in diameter, and are often called minor planets. Moons. A moon is a body that orbits a planet or an asteroid as those objects orbit the sun. There are approximately 175 known moons, which vary in size from larger than the smallest planets to only a few kilometers in diameter. Comets. A comet is often compared to a snowball made from snow found along a road that has just been sanded, a dirty snowball. Comets are mainly composed of solids that easily change to gases when heated. They are largely ices of substance such as water and methane mixed with rocky or metallic solids. Most comets are 1 to 100 kilometers in diameter. When comets get near the sun, some of their ices turn to gases. Some solids are released, forming spectacular tails visible in Earth's sky, sometimes for weeks at a time. Meteoroids. Very small solid fragments that orbit the sun are called meteoroids. Most meteoroids are only the size of a dime or a sand grain. When meteoroids burn up or vaporize, they leave a brief visual streak as they pass through Earth's atmosphere and are called meteors. If a meteoroid survived its trip through Earth's atmosphere and lands on Earth's surface, it is then called a meteorite. Some meteorites have sufficient mass to create depression in Earth's crust called an impact crater. So meteorites. Go to meteorites. I'm sorry. Meteorites go to be meteors. Okay. Evolution of the solar system. Scientists infer that our solar system started to form approximately 5 billion years ago. At first, there was a gas dust cloud many times the size of the present solar system. This cloud contained remnants of stars that had exploded, giving to the cloud heavier elements to mix with the more common lighter ones. Gravitation, perhaps aided by a shock wave from an exploding star, caused the cloud to condense into one or more mass concentrations. Look at figure 3.8 and read the caption to see how these masses have formed our solar system. Even after Earth and other planets formed, their gravitational forces pulled on the smaller clumps of matter to cause comets, asteroids, and meteoroids to collide, and the planets in what is called impact events. The planets, asteroids, and moons with solid surfaces bear witness to these impact events in the form of craters. Impact events have also been linked to global climate changes and mass extinctions. Meteorites still hit Earth, and there is a concern that this type of natural disaster could destroy a large portion of the life on our planet. Presently, an intensive scientific search is being conducted to find comets, asteroids, and meteoroids that could collide with Earth and have enough mass to result in loss of life, injury, and loss of property. The gravitational contraction of the planets, larger asteroids, and larger moons produced heat. This heat, along with the heat from radioactive decay and frictional heat from impacting meteorites, caused the newly formed planets, larger asteroids, and moons to largely melt. As a result, these bodies became layered into zones based on the density of their various elements and compounds. Number 27. Which is not included in our solar system? Polaris, the moon, meteors, asteroids. Number 28. In the last billion years, when meteorites, asteroids, or comets collided with Earth, which has occurred? Craters have formed, the whole Earth's surface has melted, all life has been destroyed, or the oceans have largely evaporated. Number 29. Today it is most commonly believed that our solar system formed 1. By gravitational collapse of a gas dust cloud. 2. From material exploded from the sun. 3. At the time of the Big Bang that formed the present universe. Or 4. By fusion of matter between the sun and the passing star. Planet characteristics. A planet's distance from the sun has a major effect on its characteristics. See the solar system data in the Earth science reference tables to find each planet's distance from the sun and other significant features and events. When the planets were forming, the sun probably radiated more energy than it does today. The high temperatures and pressures from particles emitted by the sun drove the less dense elements and compounds away from the inner solar system. The outer parts of the solar system were not nearly so hot, and the particle pressure from the sun not nearly so great. These differences in the inner and outer solar system provide characteristics that allow the planets to be classified into the inner terrestrial planets and outer Jovian planets. The former planet Pluto, because of its small size and its composition similar to comets and other distant solar system members, doesn't fit either planet classification and is now called a dwarf planet. So Pluto is now a dwarf planet. Terrestrial planet properties. The terrestrial planets are close to the sun and mostly solid. They have relatively small diameters and high densities. Their rocky surfaces are dotted with impact craters. They have few or no moons and have no rings. Terrestrial planets are the planets similar to Earth and include Mercury, Venus, Earth, and Mars. Jovian planet properties. The Jovian planets are far from the sun and are largely gaseous. They have relatively large diameters and low densities. They have no solid surfaces, though they may have a solid core, and thus no craters. These planets have many moons and have rings. The Jovian planets are the planets similar to Jupiter and include Jupiter, Saturn, Uranus, and Neptune. Motions of the planet. The planets have many different motions. They move with the solar system around the Milky Way galaxy in periods of about 225 million years. They rotate or spin around an imaginary axis, and they revolve around the planet in an orbit or path. Planet rotation. Planets spin on an imaginary axis in a motion called rotation. The period of rotation is the amount of time it takes for a planet to make one spin around its imaginary axis and determine the length of a planet's day. 6 of the 8 planets rotate in the same direction as they revolve around the sun. You can tell that planets rotate through observations of surface features made at different times. The solar system data table and the Earth science reference tables list the periods of rotation of the planets. Planet revolution. A planet's revolution is its movement around the sun in a path called an orbit. The planets revolve around the sun in a counterclockwise direction, as viewed from Polaris. Earth's orbit and those of the other planets is an oval shape called an ellipse. Within the ellipse are two fixed points called foci. Singular focus. The sum of the distance between any point on the ellipse and the two foci is a constant. That is, the sum of those distances for one point is equal to the sum for any other point on the curve. The Sun is at one of the foci of each planetary orbit in the solar system. The major axis of an ellipse is the longest straight line distance across an ellipse, the biggest diameter, and its cuts through the two foci. Eccentricity of planet orbits. The degree of flattening or ovalness of an ellipse is measured by its eccentricity. Eccentricity can also be described as the amount of difference between an ellipse as compared to a special type of ellipse called a circle. The formula to compute eccentricity is listed below and also in the Earth Science reference tables. If you measure D and L in the ellipse of figure 310 and apply the formula, you should find the eccentricity to be 0.26. As the foci of an ellipse are brought closer together, the ellipse becomes more like a circle and the eccentricity decreases towards 0. The eccentricities of the planets are listed in the Solar System Data Reference Table. If you were to draw the orbits of the planets to scale, they would look like circles to the human eye, except for Mercury. As an example, figure 311 shows Earth's orbit nearly drawn to scale, and it appears to be a circle. Varying distance of planets from the Sun and apparent solar size. The elliptical shape of a planetary orbit causes the planets to vary in distance from the Sun during a revolution. For example, Earth is 147 million kilometers from the Sun when closest, occurring on or about January 3rd. Earth is 152 million kilometers from the Sun when furthest away, occurring on or about July 4th. The difference between these two distances is only about 5 million kilometers. It is important to note that this is not the factor that causes seasons on Earth. As Earth revolves around the Sun, the varying distance between the two bodies results in changes in the apparent size of the Sun as viewed from Earth. Photographs taken on the Sun when the Earth is closest to the Sun around January 3rd illustrate that the Sun appears largest at this date and smallest around July 4th, when the distance between Earth and the Sun is the longest. Inertia, gravitation, and orbital velocity/speed in planet orbits. The planets and all other bodies that orbit the Sun and any revolving body operate under a balance between inertia and gravitation, as shown in figure 312. Inertia is the concept that an object at rest will tend to remain at rest, and that an object in motion will maintain the direction and speed of that motion unless an opposing force affects it. Gravitation is the attractive force that exists between any two objects in the universe. The gravitational force is proportional to the product of the masses of the objects and inversely proportional to the square of the distance between their centers. In simpler terms, the greater the mass of one or both objects, the more gravitational attraction there is between the objects. Also, the closer together two objects are, the greater the gravitational attractions between them. Conversely, the farther apart two objects are, the lower the gravitational attraction between them. The orbit of a planet around the Sun, or that of any other satellite, is an example of the dynamic equilibrium or balance between inertia and gravitation. The shape and size of the orbit is a compromise, or balance between the forces, as illustrated in figure 312. Since each planet's orbit has some eccentricity, its distance from the Sun varies during its yearly revolution. The result of that is that of each planet's orbital speed velocity varies during its year. When a planet is closer to the Sun, its orbital speed velocity is greatest, and when a planet is farthest from the Sun, its orbital speed velocity is slowest. The period of revolution for a planet is the amount of time it takes the planet to make one orbit or revolution around the Sun. This amount of time equals 1 year for that planet. The period of revolution of a planet is related to the planet's distance from the Sun. The closer a planet is to the Sun, the smaller its orbit, the shorter its period of revolution, and the faster its speed of revolution. Thus, the time it takes for a planet or any other member of the solar system to orbit the Sun is affected by two factors. The farther a planet is from the Sun, the longer the orbital path that must be traveled in 1 year. Also, the farther a planet is from the Sun, the less gravitational attraction between the two objects, and thus a slower orbital velocity. Question 35. The planets known as gas giants or Jovians include Jupiter, Uranus, and Mercury, Saturn, Mars, or Earth. Number 39. Which planet revolves fastest in its orbit? Earth, Jupiter, Mercury, or Neptune? Number 47. Which planet's orbit is most nearly circular? Earth, Venus, Neptune, or Jupiter? Number 50. The force of gravity between two objects is greatest when 1. Masses are small and the objects are close together. 2. Masses are small and the objects are far apart. 3. Masses are large and the objects are close together. Or 4. Masses are large and the objects are far apart.